So in this video, we're going to talk about hyperbolas. And the definition, the geometric definition of a hyperbola is similar to the definition for an ellipse with one difference. So a hyperbola is the set of all points in the plane, the difference of whose distances from two fixed points is a constant. And just as they were in an ellipse, the fixed points are called the foci of the hyperbola. So in ellipse, this word difference was replaced with sum. That's the only change here in the definition. The equations for hyperbolas will be one of two forms. You notice down here we'll either have x squared over a squared minus y squared over b squared equals 1, or y squared over a squared minus x squared over b squared equals 1. This should say, and yours does, a and b are both greater than 0, and neither one, the relationship between the two doesn't matter, just that they're both positive. But a is always the coefficient underneath the term that's positive. So if x squared has a positive coefficient, then a squared is the denominator on x squared. But if y squared has a positive coefficient, then a squared is taken to be the denominator on y squared. The variable that comes first is going to determine which way the graph will open. These graphs are going to have two branches. If x squared is first, then the graph will open in the horizontal direction. And if y squared is first, then the graph will open in the vertical direction. Notice if y is 0 in the first graph, then we have x squared over a squared equals 1. So x would have to be positive or negative a. Those are the points where the graph intersects the x-axis. So we'd have a0 here and negative a0 on the other side. Similarly, in the other case here, if x is 0, we'll have y squared over a squared equals 1. So we would have to have 0a for the intersection of the graph with the y-axis, 0 negative a for the intersection of the graph with the y-axis. So we can see at least where the graph will intersect each axis. There aren't going to be any intersection points with the the y-axis here. If x is 0, we have negative y squared over b squared equals 1. Well, we can't have a negative square equaling 1. That's impossible. So there won't be any points on the y-axis. Similarly, over here, if we have y equals 0, so if we're on the x-axis, we'd have negative a square equaling 1. And again, that's impossible. The vertices are these points where the graph intersects what's called the transverse axis, in this case the x-axis, in the other case the y-axis. So we have positive or negative a0 or 0 positive or negative a. The axis length is just that distance between those two vertices. So 2a. The way we use b is not to actually create a point on the graph, but we measure b up and down on the y-axis in the first case, or on the x-axis in the second case. And then we create what's called this central box that we use to sketch the asymptotes of this graph. So hyperbolas always have these asymptotes, these lines they get closer and closer to but don't cross. So what you want to do is connect the corners of that central box, and those should give you the asymptotes for the graph. So my sketches aren't great, but the asymptotes in the first one, the equation would be either y equals positive b over a times x or y equals negative b over a times x. I'm just thinking about slope and the fact that they go through the origin. And in the second case, we would have a over b for the slope, or negative a over b for the slope instead. So y equals positive or negative a over b times x. And then the foci are, from that definition, the fixed points where the difference of any point. So we'll sketch these foci here in a second, and then we'll talk about the definition. So the foci are always going to be away from the origin, past the graph on the axis where the transverse axis is. So here we would have 0, c, and 0, negative c. And on the other one we'd have c0 and 0, or sorry, negative c0 for the foci. And the idea would be that if we were to look at any point on the graph, take the distance between the first focus and that point and the second focus and that point, and look at the difference of those two, it should be the same as looking at the difference in those distances for any other point on the graph. So the definition is a little complicated, but the foci are connected to the geometric definition. So here we said we'd have positive or negative c0, and here we'd have 0, positive or negative c. And the relationship between a and b and c is always the same. C squared is always a squared plus b squared. So, first example here. We want to sketch the graph of this. We can see because one coefficient is positive and one is negative, this will be a hyperbola. We need a 1 where this 144 is. So if we divide everything by 144, we'll have x squared over 9 minus y squared over 16 equals 1. A squared is always the denominator on the term that's positive here. So a squared is 9. B squared is 16. So we can see a is 3, b is 4. And c squared is always a squared plus b squared, so 25, which means c is 5. Because x squared is positive here, we know that the graph is going to open horizontally. Using a, we'll go 3 to the right and 3 to the left. Those are our our vertices, and the foci are going to be on that same horizontal axis at 5 and negative 5. Can write that much down. So vertices are positive or negative 3, 0. Foci are positive or negative 5, 0. And let's see, asymptotes we can get to. If we sketch in using b equals 4, we can sketch this central box. And we can see that the slope of the asymptotes is going to be 4/3, rise over run. Positive or negative 4/3 x. Sketch those in. And then, with those sketched in, we can get the rest of the graph. So we know it goes through this point and that point, and we're going to just head toward those asymptotes. So we're not going to be more accurate than that, but that's the idea, is that these hyperbolas will get closer and closer to their asymptotes, but won't cross them. So we've got the asymptotes listed, the foci listed, the vertices listed. We could list the axis length. That's always 2a, which in this case is 6. All right. Next one, sketch the graph of 4x squared minus 9y squared plus 36 equals 0 and list and label the important features. So again, we need standard form first. So first thing we want to do is move the 36, subtract 36 from both sides. And then we need a 1 where that 36 is, so we're going to divide by negative 36 on both sides, which is going to give me x squared over negative 9 plus y squared over 4 equals 1. So I can see that negative x squared actually has the negative, or sorry, x squared has the negative coefficient. So I want to rewrite this as y squared over 4 minus x squared over 9 equals 1. And then I can see that a squared, which is always the denominator from the positive term, is going to be 4. B squared is 9. And then c squared, which is a squared plus b squared, should be 13. So a is 2, b is 3, and c is 13, square root of 13. Because the y squared has the positive coefficient, everything's going to open vertically. So I can use a, 2 up and down on the y-axis for the vertices. So it'll be 0, positive or negative 2. And then the foci I can also find using c. They'll be on the y-axis just like the vertices are. 0, positive or negative square root of 13. Square root of 13 is somewhere between 3 and 4. And then, let's see, using b, we can create that central box. So b was 3, so I want to go on the x-axis, 3 left and right. Create this central box and then connect the corners to create the asymptotes. So it looks like the slope for the asymptotes is going to be 2/3 and negative 2/3. So the equations would be y equals positive or negative 2/3 x. And then we can get the graph just by connecting. We've got one point on the graph, head toward those asymptotes. And let's see, axis length, might as well write that down. 2a would be 4. All right. Next one, instead of being given the equation, we're just given some information about the graph. Has foci positive or negative 6, 0. So remember this would be positive or negative c, 0. And vertices positive or negative 2, 0. So this is plus or minus a, 0. From those pieces of information, we can also see that the transverse axis is horizontal, which means x squared has to be the positive. So we're looking at x squared over a squared minus y squared over b squared equals 1. We can see what a squared is, and we can see what c squared is, but we need to know b squared. So using this relationship, solving for b squared, we'd have c squared minus a squared, so 36 minus 4, which is 32. And that gives us everything we need. So x squared over a squared, 4, minus y squared over 32 equals 1. That's the equation. And then the graph, got vertices 2 and -2 on the x-axis. Foci, positive and negative 6, 0, 3, 4, 5, 6. And then we can use b squared equals 32, so b is the square root of 32. That's, what, between 5 and 6? Just mark it somewhere like there. Create our central box. And then we can get the asymptotes. And then we can get the graph. Okay. Let's see. Is there anything else we needed? Find the equation, sketch the graph. Good enough. Next one, similar. Now we've got the vertices given and the asymptotes given. So vertices 0, positive or negative 6, which means we've got a vertical transverse axis. And it also means that a is 6, which means a squared is 36. I think that's as much information as we can get from that part. We could sketch those on the graph. 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And the asymptotes are y equals plus or minus 1/3 x. And let's see, if the graph is opening upward like that, for a vertical transverse axis, the asymptotes in general are y equals positive or negative a over b x, which means the ratio of a to b should be 1/3. But a we know is 6, so 6 to b is 1/3, which means b is going to be 18. It's big, right? Let's just go back and look at this for sure. So if we're opening on the y-axis, yeah, we want a to b, and the vertices are 0 plus or minus a. So that ratio is supposed to be a to b, and we've got a given as 6. So b is 18. Yeah, that's right. So we might want to change the scale of this thing here. So we know that b squared is going to be 18 squared. And that we want to know, I guess, c squared would be 36 plus 18 squared. That's large 2. All right, so let's make each of these tick marks 3. So we've got 3, 6, 9, 12, 15, 18, 21. This would be 24. And same thing here, 24. So each of the tick marks is 3 units. So we've got the equation would be y squared first over a squared, which is 36, minus x squared over b squared equals 1. So on the y-axis, our vertices 0, 6 and 0, -6. And to sketch the asymptotes, we need to use b in the x-axis direction is 18. That way. So then we'll have something like this for our asymptotes. And then the graph. Opening vertically. And the ratio, these asymptotes have the right slope, 1 to 3, and positive or negative 1/3. So everything looks good, the numbers are just big. Another one. So the hyperbola has foci 0 plus or minus 1. So this is 0 plus or minus c. But that also tells us that the transverse axis is vertical again. Since those are on the y-axis. And let's see. The transverse axis has length 1 unit. The transverse axis length is always 2a. So what we know is 2a is 1. So putting this together, we've got c is 1, a is a half, c squared would be 1, a squared would be a fourth, and we always know that c squared is a squared plus b squared. So b squared would be c squared minus a squared. So in this case, that's 1 minus a fourth. So b squared is 3/4, so b would be positive or negative square root of 3 over 2. So, equation we can get, we know that because there's a vertical transverse axis, y squared is going to be first. So y squared over a squared minus x squared over b squared equals 1 is our general form. So what we want here is y squared divided by a fourth minus x squared divided by 3/4 equals 1. Let's make that look nicer. 4y squared minus 4/3 x squared equals 1. So we don't have complex fractions. There's the equation, and then the graph. We've got up and down a half for the vertices. So let's say this is 1, 2, 3, 4, 1, 2, 3, 4 for our scale. So each tick mark is 1/2. The vertices are on the y-axis. And then we'd use square root of 3 over 2 for our b to generate this central box in our asymptotes. Square root of 3 over 2 is going to be somewhere between, what, a half and 1 somewhere. So the best we can do is estimate that and then sketch in the asymptotes and then connect the rest of the plot. Take the vertex on each side and head toward the asymptotes. In example 6, we're given the location of the foci, and we're given the location of one of the vertices. So one vertex at 2, 3, and the foci are at plus or minus 6, 3. So let's sketch that much, fill in those points at least. So 6, 1, 2, 3, 4, 5, 6, 3, and negative 6, 3. And then one vertex at 2, 3. So if we're going to look for the equation and sketch the graph, we need to know A and B and C. And we need to know where the center is. And the center has to be halfway between the foci. So midpoint between the foci, which in this case, let's see, between 6, 3 and negative 6, 3 would be 0, 3. So the center of this thing is 0, 3. And then once we know where the center is, we can determine quite a few of the values. At least we can tell, because the foci are along the same horizontal line, that this hyperbola will open left and right. And if this is one vertex, then A, which is the distance between the center and a vertex, would be 2. And the other vertex would be at negative 2, 3. So a second vertex would be at negative 2, 3. Our center, we already have written down, 0, 3. Don't need to write that down again. And then we can tell, because now we know where the center is and we can see how far away the foci are, that C would be 6, the distance between the center and the focus. And then we can figure out what B would be, because we know that C squared equals A squared plus B squared, which would imply that B squared is what we're looking for, is C squared minus A squared. In this case, that would be 36 minus 4, so 32. So B is going to be the square root of 32, which is the same thing as, 4 times the square root of 2? And we could say that's between 5 and 6, because square root of 25 would be 5, and square root of 36 would be 6. So for our rough sketch of the graph, that's good enough, and we can figure that value without a calculator. Okay, so let's see, because this opens sideways, we know that the x should come first, and then y group will have a negative coefficient. And because the center is 0, 3, we would have x minus 0 squared and y minus 3 squared. We want a squared underneath the x's. A squared is 4. And b squared underneath these y values, that would be 32. And in standard form, we want 1 on the other side of that equation. And now the rest is just to get the sketch of this. We have already labeled the center and the vertices and the foci. So now we want to just use this b value to get our central box. So between 5 and 6 up and down from that center. 1, 2, 3, 4, 5. So a little bit higher than that. 1, 2, 3, 4, 5, and a little bit lower than that. So let's sketch the central box. And connect its corners to get the asymptotes. And then go from our vertices out toward the asymptotes. There we go. Then it's also asking us to list the equations of the asymptotes. Let's think about the slopes. We want always the change in y over the change in x. Since the vertical distance up from the center to get to one corner would be b and the horizontal is a. For this slope, we want the ratio of b to a on the positive slope side and the opposite of b to a on the negative slope side. So for 1, the slope would be square root of 32 over 2, or let's do this, 4 square root of 2 over 2, which is 2 times the square root of 2. And for the other, we would have negative 2 square root of 2. You can see the slopes are just opposite sign. And then those both of the asymptotes go through this same point, which is 0, 3. So we're using point 0, 3 and slope either plus or minus 2 square root of 2, depending on the line. So we'd have y minus 3 equals positive or negative 2 square root of 2 times x minus 0. And then we could solve that for y. Y equals positive or negative 2 square root of 2 times x plus 3. So the two lines would have opposite slopes but the same y-intercept. All right, then moving on to example 7. My spacing on my copy here isn't that good. Determine the equation of the hyperbola whose graph is shown. So this time we don't have to sketch the graph, but we need to come up with the equation. First thing we want to notice is the center, which in this case appears to be negative 2, 4. And then let's see what's next. We could notice that the vertices are at 0, 4 and negative 4, 4. And the distance between the center and a vertex appears to be 2. So A, remember, which is the distance between the center and the vertex, appears to be 2. And then we can figure out the ratio of A to B if we draw this line up and down through the vertex. We see that that distance up is 3. So if we picture that central box, and sketch it in, we can tell this distance here is 3. So for the equation, that's really all we need to know, the center and the value for A and B. We need to know whether it opens horizontally or vertically, so that we know whether the x's should have the positive coefficient or whether the y's should. In this case, since it opens horizontally, we want the x's to have a positive coefficient and the y's to have negative, which means we'll have x plus 2 because of the center being negative 2, 4. And we'll have y minus 4 as the squared group there. We want a, always a squared underneath the first term, the one with the positive coefficients, 4. B squared underneath the other one. So that's all we need for that. Let's also list where the foci are, just for completeness. So the foci are at, it would be left and right of the center, and we need to know what c is. C squared is always a squared plus b squared for hyperbolas. So that's 4 plus 9 in this case. So c would be the square root of 13. So we want to go that distance left and right of the center, which means we're changing the x. So negative 2 plus or minus square root of 13, 4 for the foci. And then let's write down the equation for the asymptotes also, just for the practice. We want change in y over change in x along these asymptote lines. So in this case, we want the ratio of b to a, since b is the vertical change and a is the horizontal. So 3/2, it appears. So the slope is either going to be positive or negative 3/2, depending on which side we're on. And for a point, we can use the center. The asymptotes always go through the center, which in this case is -2, 4. So if we use point slope form for the equation of a line, y minus y1, which is 4, equals the slope, which will be different in each one, times x minus x naught, which would be x plus 2. So if we solve for y equals positive or negative 3/2, x plus 2 plus 4. And that should be everything we need to do there. So the key was sketching in that central box, make it wide enough to catch both of those vertices, and then figure out where it hits the asymptotes and draw it in that way, and use that to determine A and B. Last one, again, we need to complete the square 2 times, one for the y group and one for the x group. So completing the square, twice, so that we can get the information we want. So we have it in the standard form first. We want to factor out the 4 from the y's. And then factor out the -1 from the x's. And move the 4 to the other side. Like that. Leave a space to add something to each group. Always take half of this coefficient and square it. And that's what you want to add in. So -2 divided by 2, that's 1, -1, but when we square it we get 1. And then we'll take half of 4 and square it, we'll get 4. And then we've got a bunch of 4's we need to put on the other side. So here, when we wrote down this 1, it was really a 4 times 1. So we want to add that to the other side as well. And we wrote down this 4, it was really times -1. So we want to subtract that from the other side also. So it ends up that we still just have 4 on the right side, but we need to be careful about that. So we've got 4 times y minus 2, or sorry, y squared minus 2y plus 1 minus x squared plus 4x plus 4 equals 4. And then we want to rewrite these trinomials as binomials squared. This group would be y minus 1 squared, and the other group would be x plus 2 squared. So remember, you want the square root of the first term, the square root of the second term, and then choose the sign that matches the sign on the middle term when you're factoring those. Then you need a 1 here, so you want to divide everything by 4. So we're looking at, in standard form, y minus 1 squared over 1 minus x plus 2 squared over 4 equals 1. So just by looking at the equation, let's list what we can see that the center from our shifting would be, it looks like x plus 2, so -2, and y minus 1. So -2, 1 for the center. Because the y squared group has the positive coefficient, this opens vertically. And let's see, the a value would be the square root of 1, and the b value would be the square root of 4, so which is 2. So with that much information, let's put a sketch together. We could also write down, since we're thinking about it here, that c squared is a squared plus b squared, which in this case would be 1 plus 4, so 5. C would be the square root of 5. Okay, so now let's sketch this thing. Center, -2, 1. And opens vertically. So A, we want to go up 1 and down 1. So we can see that the vertices are -2, 2, -2, 0. And to get this sketch of the central box, we want to go 2 to the right and left of the center. And then we can sketch in our asymptotes. So we've got the vertices, and now we can find the foci. Sorry, there aren't any foci in ellipses. Let's get next the equation of the asymptotes. Again, the first thing we want to do is figure out the slope. And this time, since the parabola or the hyperbola opens vertically, A is the change in the y and B is the change in the x. So we want the ratio of A to B. So the slope for these asymptotes will be 1/2, positive or negative depending on the side. And a point that they both go through is the center of the hyperbola, which was -2, 1. So the equations will be y minus 1, we're using point slope form, so y minus y naught equals the slope, positive or negative 1/2, times x minus x naught. In this case, that's x minus -2, so x plus 2. If we solve for y equals -1/2 x plus 2 plus 1. So we've got the graph, we've got the vertices. The center, everything looks good. And I mentioned that this didn't have foci, but certainly it does have foci. I was not thinking. So the foci for the hyperbola are going to be the center up and down the value of c. So the center had x coordinate -2, and we want to change the vertical. So 1 plus or minus square root of 5. So let's say square root of 5, that's just over 2. So we want to go just over 2 up. So 1, 2, and a little bit more. And just over 2 down. 1, 2, and a little bit more. So there are our foci. -2, this would be 1 minus square root of 5. And this one would be -2, 1 plus square root of 5. Alright, so hopefully these hyperbolas are making some sense. Good luck.